Okay, so what we're going to do today is we're going to finish up the note sheets from yesterday. We started them, we got to this point here. Yes. Yes. So we're going to look at this one here. So we did one of these already, the difference of perfect cubes and sum of perfect cubes. We did three examples, I believe. 2 or 3 examples of that. Then we did one where there was a greatest common factor. Now, looking at this here, most likely there is going to be a greatest common factor. Because when I look at this here, well, the 16 is negative, yes? And x to the 5th is not going to be a perfect cube. Because, well, 5 does not divide by 3 evenly. We can't simplify that evenly. So there's going to be at least a greatest common factor of a negative and a x squared. Because there's at least x squared in common with both, yes? Is there anything else in common with both of these here? Well, 2 will definitely go into both of them, yes? Will 4 go into 250? Because I know 4 will go into 16, but would 4 go into 250 evenly? Well, you can do 250 divided by 4. If we divide it by 4, well, 5 would give us, well, we do 6. 10, 2, no. 4 does not go into it. So the biggest number we could have is negative 2x squared is the greatest common factor between both of these. So 2x squared is the greatest common factor, and we can factor that out. And when we factor that out, what we end up getting is, well, negative out of a negative makes it positive. 16 divided by 2 would be 8x to the third, because we pulled 2 x's out, so it reduces 5 down to 3. Well, again, negative pulled out would make this positive. 250 divided by 2 will be 125. And x squared factored out from x squared will simplify out completely. So any questions on this here? Any questions on this greatest common factor being factored out? Okay, now let's see if we can take the cubed root or see what the cubed root is. 8x cubed and the cubed root of 125. And really, also, when we're taking this cubed root, we're not only just checking it, we're also seeing what a and b are, so that we can plug them in easier. I didn't mention that yesterday, but really, when we take the cubed root, we're finding our a and b values. Now, the cubed root of 8 is? 2. Cubed root of x cubed is x. And what's the cubed root of 125? 5. The cubed root of 125 would be 5. Okay. Now we set up the, what I call a tractor trailer, because we have 3 spaces and 5 spaces. Yes. Yes. So let's do the signs. So the signs, so they would be the same, opposite, always end on a positive note. Same, opposite, always end on a positive note. So for this here, since it was plus to begin with, we would have plus, minus, plus. Any questions on the signs? So let's do A, which would be our 2x. So in our first spot, we would have 2x. Then we move over to the second set of parentheses, and we would have what? 2x squared. 2x to the first, and then 2x really to the 0 power. And anything to the 0 power is 1. So we don't write it in. Any questions on how we plugged in the a terms or the 2x? Okay, let's plug in the b terms. So our b terms would be 5, nothing with the 2x squared, Then we'd have 5 in the middle, and then lastly, we would have 5 squared. Any questions on any of this here? Any questions on any of this here so far? So let's simplify this a little bit. Well, the 2x plus 5 doesn't change. Well, 2x squared, well, the 2 is 2x. Both of those would be squared, so 2 squared would give me 4, and x squared is just x squared. Minus 2x times 5 would be 10x plus 25. And that's as simplified as it gets, because remember, the quadratic that comes out of a cubic, a sum or difference of perfect cubes, will never factor. Bless you. This does not factor, so we're done. Any other questions on the sum and difference of perfect cubes? Do we feel comfortable with doing these here? Yes? Because the sum and difference of perfect cubes really follow a set pattern, don't they? Because if it's minus, the signs are negative, positive, positive. Find the cubed root of the first term, cubed root of the second, plug them in. And that's it. Any questions on this here? Would we like to look at another sum or difference of perfect cubes?
Yes.
Which one?
4.
We can do both. So this here. So there's no greatest common factor, so I'm going to look at the cubed root of both. So what's the cubed root of a cubed? This would be cubed root of 27. So this is a sum of perfect cubes because we have a plus in the middle. Now I can set up my parentheses. So the signs are what? The same, opposite, always end on a positive note. So we would have plus, minus, plus. So let's start off with A. In the first spot, we would have A. The next spot, this spot here, we wouldn't have anything because it doesn't have A. And the first spot over here would be A squared. A to the 0. A squared, A, no A. Our B, you plug it in here. No B, 3 to the first, and then 3 squared. Any questions on how we plug this in? Any questions on any of this here so far? Now we can simplify a little bit. We would have A plus 3. Well, A squared is just A squared. A times 3 would be 3A plus 9. Any questions on this here? That's it. Now looking at number 5, there might be a greatest common factor. Is there a greatest common factor between 6z to the 5th and 750z squared? Six z squared. Is 6 a perfect cube? Is there a number times itself 3 times that gives me 6? No. Because 1 cubed, 1 times 1 times 1 would give me 1. 2, so if we do 2 cubed, 2 times 2 is 4, times 2 is 8. So our smallest perfect cubed is 8. 8 is the smallest number that we can take the cubed root of evenly, yes? So anything less than 8 will not be a perfect cube. Well, the number after that, 2, is 3. 3 to the third is 27. 4 to the third is 64. So kind of having some of them, knowing what they are, it's helpful, because then we can see what are the perfect cubes. So this here, I have to factor out 6z squared. Well, 6 out of 6, well, that gives me 1. But I'm left with z to the third minus 750 divided by 6. If I pull 6 out of 750, 125. And that's it, because we pulled out both z's. Now, are these the sum or difference of perfect cubes? Oh, yes, because I can take the cubed root of z to the third. And I can take the cubed root of 125. Well, the cubed root of z to the third is z. The cubed root of 125 is 5. Well, it does help that we've already taken the cubed root of 125 before. Let's look at the signs. So the signs would be the same, opposite, always end on a positive note. So the same sign would be negative, because what's inside here is negative. The opposite would be always end on a positive note. There we go. Marker anyways. Okay. There we go. That's it. Just wanted to move those over a little bit. So any questions on the signs so far? Any questions on anything we've done so far? Okay, let's look at the A terms. A would be z. It was what was first. So we'd have z. Here, z squared. And then z. Now our b would be 5. So we'd have 5, nothing. 5 in the middle, and 5 squared. So let's simplify this a little bit. So this would be z minus 5 times z squared plus 5z plus 25. And that'd be it. And that would be it. That's all we'd have to do for this here. Any questions on any of this here? Yes? No? Okay. Be ready for the next problems. Yes? Now, the last type of factoring we're going to look at is something called grouping. Grouping. And for most part, what we're going to look at is grouping. For what you'll be doing is we're going to group the first two and the last two. Or another way to think about this is double GCF, greatest common factor twice, is really what grouping is. Because when I look at these first two terms, just the first two, z cubed and 5z squared, is there a greatest common factor between them? Bless you. So just the first two, z cubed and 5z squared. So z cubed and 5z squared. Is there a greatest common factor between just these two terms? Well, there is. It's not just z, it would be what? Z squared. Because I can factor z squared out of both of these here. Well, z squared out of z cubed would leave me with z. Z squared out of 5z squared would be plus 5. Well, 20, so now we'll look at the other two, negative 4z minus 20. So 4 is a greatest common factor between these two, yes? I would take out not just 4, but I would take out the negative 4, because they're both negative, yes? So take out negative 4. And let's see what happens, because something special is going to happen. What happens when I divide or take out negative 4 out of negative 4z? I'd be left with positive z, yes? Well, again, with negative 20 and negative would leave me with plus. 20 divided by 4 would be? Okay.
So if you take negative 4 minus negative 4z, why would you have positive?
A negative and negative make a?
Yeah, but now you're left with z. That's 1z.
What's negative 4 times z?
4 is 0.
What's negative 4 times z? Negative 4 times z. What does that give me?
Oh, negative 4z.
Yep. You're good. So we're just pulling it out. Now, if you want to make sure, you can multiply it back through and see if we got the same thing. Now, did somebody notice something that's similar with both of these? These are the same, yes? I can factor it out. Because it's shared in common in both, yes? Because the greatest common factor is the biggest thing that's in common in all the terms. So now these two terms share a common factor of z plus 5, yes? Well, if I factor z plus 5 out of the first, I'm left with z squared, yes? If I factor it out of the second, I'm left with negative 4. This is why I factored out the negative 4, because again, when I factored out the negative, it made both of those terms, what, positive? So they matched. That's what grouping is we're really doing greatest common factor twice, because when I factor out the first term out of both of the ones we grouped, it gave me something in common with both of them that I could factor out again. Questions on this here? You'll see how this works with grouping, because we're putting stuff together that we can simplify. Any questions on this here? Is this factored completely? Well, we see that we have x or z squared minus 4. That has a exponent greater than 1, yes? So we need to see, will z squared minus 4 factor? And it will, because this is a difference of perfect squares. There's not a sum of perfect squares. That doesn't work. It doesn't have real solutions. It's not factorable. But if I have a difference of perfect squares, it will factor. So we'd have a positive and a negative. The factors of z are and z. And what are the factors of 4 that we would use? 2 and 2. And this would be it. And we could check it. This here, z times negative 2, which would be negative 2z. 2 times z would be plus 2z, which gives us 0 like we wanted. So when we group 2 of them, the first 2 and the last 2 terms together, and find the greatest common factor. Once we factor that out, we factor out what's in common again, and get down to our solution. Now we need to make sure that this is factored completely, and the z squared minus 4 wasn't, so we needed to factor it one more time. Because big idea math is going to want you to factor these completely, all the way down. Questions on this here? Let's look at this one here. So again, I'm going to group these two and these two. Let's start off with the first two, x cubed minus 2x squared. And I'll give you a little bit of a hint and kind of some tricks as we look at this one. Now, what is the greatest common factor between x cubed and 2x squared? Just x squared. Because the x cubed doesn't have a factor of 2, we wouldn't pull it out. Now, x squared factored out of x cubed, or x cubed divided by x squared, or taking 2 x's away from x cubed, would give me what? X. Because I take 2 away from 3, and I have 1. Now, if I take 2 away from 2, I'm just left with x minus 2, yes? This is what's left inside. Any questions on this here? Okay, now let's look at the other set. This is where my kind of hint I didn't say in the first one is going to come into play. Now that we kind of have an idea and grasp of what this grouping is, or double factoring as I sometimes call it, what we're wanting over here is to have a set of parentheses that's going to match a what? X minus 2, yes? Because if I have both of those sets of parentheses as x minus 2, we can simplify further. We can factor again. So I need this negative 9x to become what? X. But it has to be what? Positive, yes? So what would I need to factor out of negative 9x to make it positive x? Negative 9, yes? What happens if I factor negative 9 out of 18? It becomes negative 2, yes? So what would I factor out? Negative 9. So factoring out the x squared is pretty easy. It's easy to see that one, yes? But does that also give me a hint at what I need to factor out of the next one? Yeah, it kind of gives me a blueprint of what I need. Because it's going to leave me with x minus 2. Now what can I factor out? I can factor out the x minus 2, which will leave me with x squared minus 9. Any questions on this here? Are we good with this here so far? Yes? This one? So what do they have in common? So I factored out the x minus 2 from both. So when I factor it out of the first term here, I'm left with x squared. When I factor it out of this one here, I'm left with negative 9. And up to this point, this is an odd step because you've never actually factored something that's more than one term for a greatest common factor. But it works just fine. We can do this. So is this factored completely? No, x squared minus 9, is that factorable? Yes. Since it's negative, the signs are factors of x squared. 3 and 3. Because x squared minus 9 is the difference of perfect squares. Any questions on this here? Any questions on anything we've done so far? Are we ready for the next one? Yes? I feel like you all are getting the hang of this for the most part, yes? So let's look at number 7 first. We'll come back to 6 if we need to. But let's look at 7. So let's look at this first. 3y cubed plus y squared. What would our greatest common factor between these two terms be? Y squared. And if I factor it out, I'd be left with plus 1. When something factors out completely, because we had y squared and I pulled both of them out. The number that is left is 1. Whenever something is factored out completely, the number that we write in is 1. It has to be 1. It cannot be 0. Okay? Now our other two terms. So what would we need to factor out to get 9y to be the same as 3y? We need to factor out what? 3. And it would be positive, yes? So I just write plus 3. Because 3 factored out of 9y would be 3y. 3 factored out of 3 would be plus 1. Well, now we have something in common with both terms, yes? So we can factor out the 3y plus 1. So I'll factor it out, 3y plus 1. Times, what would we have? Okay, get there in a second. Are there any questions on anything we did for this here? Is this factored completely? So y squared plus 3, can we factor it? So since it's positive, our signs would be the same. But I don't have a middle term, do I? No, I do not. Okay. It'd be nice if there's an easy way to check to see if this is factorable, right? If this is a factorable thing. Let's use this here. Well, where's this from? What did I just pull this from? There's an equation. I remember what equation this is. The quadratic formula, yes, negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, one of the things that you should notice is that when this came out to be a whole number, we end up normally getting either whole number answers or fractional answers, yes? We didn't get ugly decimals. So if this came out to be a whole number, we had whole number answers, yes? So let's look at this here. What's the value of b? I don't have a b term, do I? Because this is coming from our, let's say, I'll use y, ay squared plus by. Do I have a by term in this? No, so it would be, so if I plug this in for this one here, it would be 0 squared minus 4. Well, a is 1 and c is 3. And you could type this into the graphing calculator. Well, 0 squared would be 0. Negative 4 times 3 would be negative 12. Is this going to even be a real number? No. Because, well, the square root of negative 12, well, the negative would come out as I. And the square root of 12 is 2 square root of, not 2, 2 square root of 3. Is that a real number or even a rational number? No. So is y squared plus 3 factorable? No. That's why I wanted to show you this one. This one here, we stop at this point. It is factored completely. This here would be the answer to it. Not the answer for this problem. This is the answer for the problem. But I would have to solve for this here and work backwards. So it is possible to do it that way. We're not going to have you, especially on this assignment, you won't have to do that. So the sum of two cubes is not factorable. The sum of two cubes, or sorry, not cubes. The sum of two squares, or here, a square and a number, doesn't work. Would have two things added together, one of them squared. Most likely it doesn't work. But the square root of b squared minus 4ac, this is a good way to kind of check to see, is it factorable? Is if this comes out to a positive number, a positive whole number after you square root it, doesn't have I, doesn't have a nasty decimal, then most likely it will factor. But like this here, if I have anything with I or a non-repeating, non-terminating decimal, it does not factor. It does not factor. Does that make sense? So this here's a way to check it, to see will it factor. Any questions on this here? Any questions on any of this here so far? Do we need to see another example of grouping? Are we good with grouping? And that's it. We are done with this here.